No, I forgot. I just turned the recording on. Sometimes you got to be careful. So sometimes I forget to turn those on. So here we have should we do number 2, or do you need to do odds only, or?
No, we can do number 2.
Okay, and then once you get the hang of this, we'll go to some of these more difficult ones.
Okay.
All right. Okay, let's just start. What's the first thing?
It's 24y squared dy dt plus 2x dx dt, and then 0.
Okay.
And then subtract the 2x from both sides.
Like that little trick?
I do like that.
You know, I've never done it before. Tonight's the first time I've ever seen it. I think probably because it's all of these problems, we're going to end up with 0 on the right side.
Yeah, I think
If
so.
0 on the right side, you can do that.
And then divide both sides by 24y squared.
Okay. And now substitute.
And then it would be 2 times 3 times, let's see, 2 over 24, and then y is -1 squared.
All right. I'm going to assume that when we get to this step, you know how to go from there. We can cover harder materials if we don't spend our time doing the simple arithmetic. Okay. 3. Let's just do 3 to get you up on how to apply the product rule. Can be a little tricky. Implicitly differentiating with product rule. Okay. Go ahead and start.
Let's see. So that would be, this is where I always get messed up.
Well, let me put parentheses around it. You know there's a plus, and there's got to be 2 things here and 2 things here.
Okay. So it's...
This thing is, it's usually written like this. U v prime plus u prime v. In other words, the opposite.
Okay.
So it's always one thing times the derivative of the other plus the other thing times the derivative of the first.
Okay.
Okay, so let me erase those and tell me what to put in here.
So it would be 2x times, let's see.
Let me make a little more room.
Okay. And then so I'd be taking the derivative of y?
Correct?
Okay, so 1, and then it'd be dy dt?
Right.
Okay.
Plus
plus y, and then 2 dy dt, or dx.
dx dt, exactly. In other words, you only, because we weren't taking the derivative of y, we don't need to follow that with a dy dt. In this part here. Okay, now the rest of it's fairly straightforward.
Yep, minus 5 plus 9y squared.
Hold on. Minus 5 what?
Oh, dx dt,
Okay.
sorry. Then plus 9y squared dy dt.
And this time I'm not going to be able to do that little trick. Okay, we're solving for dy dt. So we have a term here that has a dy dt in it, and we have a term there that has a dy dt in it. So let's leave those on the left, move everything else to the right.
Okay.
So we have d, and not only will we leave it on the left, let's factor it out, because we got 2 up. So what ends up on the left?
It would be 2x plus 9y squared.
And on the right, we have these 2 terms, opposite signs. So we'll put this one first, and then subtract this one. I could factor that out, but you don't really need to given the nature of the problem. In other words, since I'm merely going to be substituting for these, it's just extra work to factor it out and doesn't particularly advance it any. So again, they give us all 3 values. So it's just a question of plugging in. So go ahead and plug in for me. 5 times.
5 times -6 minus 2 times -2 times -6 and then 2 times 3 plus 9 times -2 squared.
Okay. Let me just caution you about one thing. See this string of minus signs in the numerator?
Yep.
It's sometimes really easy to confuse one of them for subtraction. In other words, this is all multiplication, and this is subtraction here. But it's real easy. It's kind of like when you're solving the quadratic formula and you have minus 4ac and the c ends up being negative. It's real easy to treat that as subtraction instead of a multiplication by a negative number. You know what I'm saying? In other words, this is -2 times -6, which is positive 12, times 2, which is 24. So it's minus 30 minus 24.
Right, okay.
Okay? And I didn't treat either of these as subtraction, merely as negative signs on the numbers. All right, let's do some harder stuff. 4 is no harder than 3.
Okay.
In other words, we're going to have to apply the product rule right here.
Yep.
Just like we had to apply it there. So let's do 5. Here we have to use the quotient rule. Okay, so
okay, so I want to start with the bottom, right?
Right. Start with the bottom, end with the bottom squared.
Okay. So x minus y times 2x and then plus, okay.
What goes next to the 2x?
The dx over dt, okay.
Always.
And then plus 1 or dx or dy over dt.
Minus, let's see if I can widen this a little bit, just for the moment.
Then minus x squared plus y.
And let me use brackets there, parentheses there.
times, it would be dx over dt.
Let's see, we're taking the derivative of the bottom.
Yep. So it'd be 1.
Be dx over dt minus dy over dt.
Okay.
Right? Because it would be 1 times dx dt plus minus 1 times dy dt.
Okay. And then equals 0.
Right. Now, again, I can't do that trick because I got multiple dy dt's. Let's see what the best way to do this algebra is. I could, in other words, this is relatively difficult algebra, right?
Right.
To simplify, to solve for dy dt, we could certainly do it, multiplying that binomial by that binomial. We're going to have some number of dy dt's, a couple of them. Isolate, I'm going to have to multiply this binomial by this binomial. So that gets pretty complicated and tough. Why don't we make it simple by just start plugging in now, and then it's going to be easier to solve everything. So this is 5. Let's see, that's here, right? Yeah. Now hold on. Narrow it up again. Okay, so let's substitute before solving, and I think it'll become apparent to you that it'll be easier to solve for dy dt if we do that.
Okay,
because this is going to be,
so
we're going to end up with a lot of terms here. You know, when you multiply a binomial by a binomial, you get 3 terms. Same over here. So we're going to end up with 6 terms. And I can reduce those by substituting now. So x minus y is 2. Two x is 8. That's 2 plus dy dt minus x squared is 16 plus 2, so that's 18, x squared plus y, times dx dt is 2 minus dy dt. All of that's equal to 0, right?
Yep.
Now, I think this will be easier to solve for dy dt. Now, let's distribute some of this. I'm going to multiply the 2 times the 16, so we have 32 plus 2 dy dt minus 36 plus 18 dy dt. Now hold on, I just made a mistake. Can you see what it was?
It should it be minus
18? If I remove the parentheses, everything's right.
Okay.
So my mistake was putting in the parentheses. I was attempting to remove both sets of parentheses. And, well, usually I should move them one at a time. But you can see that this negative sign distributes to that 36 to give me negative 36. And then that negative sign is going to turn this negative positive. This negative 18 dy dt, because I still have to multiply that 18 by that. Okay, so I now have this. Okay, well, it's getting simpler.
Dave, if you need any help on this stuff, you know, just give me a call. I'm available 24 hours a day.
honest, this is the first time I've seen something like this where it's easier to solve for it if you substitute before solving for it. Significant.
Yeah, I like that.
I can combine the 32 and the minus 36 now, so I get minus 4. Well, I got 2 of those and 18 more of them, so I got a total of 20 dy dt's. This is all equal to 0, and now it's solving quite easily. dy dt is going to equal 4 divided by 20, or 1/5. Okay?
Yep.
All right. Let's see. What next one shall we try here? How many of these are you supposed to do? Just
those 8.
Just these 8? Okay.
Yep.
Oh, we'll just do them all then.
Okay.
Especially if we're going to run into stuff like that. Yeah, hold on. Let me see if I can get this as wide as possible. Okay, so I was going to say, why do they keep putting just numbers on the right side? And these odd numbers at that. Right? Because these numbers are all going to go to 0 no matter what they are. Maybe they're just trying to confuse us. Okay, so how do I start this one? I won't rewrite it from scratch, and I'm going to try to write smaller since there's so many terms.
Okay. So it'd be, let's see, x to the third plus 2y times, let's see, 2x.
Which one are we doing?
Oh, sorry.
That's okay.
3y squared, and then dy dt minus 8x, and then dx dt.
So that's the bottom times the derivative of the top.
And then it'd be
I can't write small enough.
y to the third minus 4x squared times 3x squared, and then dx dt.
Well, you know what we forgot to do? It just occurred to me. On number 5, we forgot to divide by the bottom square, did we not?
Yes, we did forget to do that.
Ah, so make sure if you've got notes in front of you, or if you're following my notes, let's not forget to do that. It's not going to make it much different. You're going to end up with x minus y squared, but no more dx dt's or dy dt's. So it'll be relatively simple to substitute for that. I just forgot to do it. So let's see. We still got the derivative of the bottom.
Yeah, so 3x squared, and then dx dt plus 2 dy dt. And then over, yeah, x to the third plus 2y squared.
Okay. And again, I think it makes sense to substitute rather than trying to solve this monstrosity for dy dt. So tell me what to write next.
Okay, so it would be, let's see, negative 3 to the third, which would be negative 27.
Okay.
Plus negative 4.
So minus 4. Okay, that's this term.
And then let's see. 4, so then, yep. And then negative 3. And then dx, or yeah.
Well, you really want to make sure you keep your parentheses straight here.
Okay.
If you forget them, it's real easy to get a sign wrong.
Yeah.
Okay, so y cubed is minus 8 minus, and you can see how you could easily get a sign wrong. You end up with a string of minuses. We're going to end up probably having about 8 minuses in this term here. So let's see. That was minus 8 minus 4 times 9, 36. 3 times 9 is 27 times 5. Plus 2 dy. Hold on. I'm trying to expand this. Plus 2 dy dt. Okay, so what's the next thing?
Okay, and then solve them all so that it gets down. So that would be negative 31.
It's probably best to do this almost a step at a time. Just I think, just because you increase the chances of getting it right, not making an error. 15 times 8 is 120, so what goes here?
Let's see. Would it be plus 120?
Mm-hmm. Now, minus, goes here?
Negative 44.
So 135. Now, distribute more. Got a calculator?
I do. Okay, so the first one would be negative 372 dy dt minus 4,030
and I'm going to use parentheses to distribute these two.
Okay. And then it would be a negative 5,940. And then minus 88 dy dt.
Now let's remove parentheses. Changes this to a plus and this to a plus. Right? In other words, both of those minus signs I can remove, change it to a plus, and change that to a plus. Okay, now gather all the dy dt's. How many do we have?
2.
Okay.
Exponential.
So that's minus 288 dy dt. And what is this number right there?
That would be 1,000, yeah, 1,910.
All that's equal to 0. So dy dt is equal to 1910 over 288. Negative, but it turns into a positive. So this is almost more of an exercise in algebra than it is. I mean, you have to know the calculus for sure. You have to be able to implicitly differentiate and, of course, apply the product rule and all of that good stuff. And I did it again.
Oh, the bottom.
I sure did. So let's see. Let's go back to, this is all the top, right? Yeah, in other words, this is the top. So I can go from here and put in the bottom squared, which is x cubed plus 2y squared, which becomes 64 plus 4 squared, or 68 squared, which is what number?
68 squared.
Notice what's going to go on here. Doesn't matter what that number is. Even though I ignored it accidentally on number 5, it's not going to affect our answer on number 6. You see why? What's 68 squared?
68 squared is 4,624.
Now the next step is to multiply both sides by 4,624. Leaves the 0 on the other side, gets rid of the denominator.
Oh, okay.
Whenever you have a rational function, quotient, that's equal to 0, you can ignore the denominator. The numerator has to be equal to 0. That's the only way any quotient can be equal to 0, is if its numerator is equal to 0. So the fact that I ignored it on 5 won't change the answer. Although I don't think we came up, I was going to let you get that answer. But yeah, it just occurred to me that adding the numerator or the denominator squared doesn't change anything. It quickly disappears, and we're back to what we had, which was 1910 over 288. Interesting. Okay, let's look at 7. 7 and 8 have these ugly logs and e's and stuff in them, huh?
Yeah, these ones I always have trouble with.
You won't. After we do 1 or 2 of them, they're pretty straightforward, actually. As long as you remember the derivatives for these things. Okay, so let's start. We got to apply the product rule here.
Okay, so product rule. So does it matter where you start?
No, it really doesn't. Although I would suggest that you be consistent when you do it. In other words, you can do x times the derivative of this, or the derivative of x times this as your first term. I always do it this way. I always do that times the derivative of the second thing. Okay. And that way I don't have to worry. The thing is since it can be done in either order, I never know quite which my student is doing. So let's be consistent with one another even, and then it'll be easier for me to follow. Okay. So x times the derivative of this. What's the derivative of this?
Is it y e?
No. What's the derivative of e to the x?
Oh, just be.
Be to the x. Right. It's the only function whose derivative is the same thing as the function, other than 0. 0 is always also that way. It's the only other one. And 0 doesn't have any implications, whereas this has tremendous implications. the fact that the derivative of e to the x is e to the x is huge for calculus. Okay, so this would be x. The derivative of e to the y is e to the y. But since we're taking the derivative of this, need that.
Okay.
What's next?
And e to the y times dx dt. And then 2. Well,
Differentiate it.
okay, so that one would be
What's the derivative of that? What is natural log of 2? Is that a number or a variable?
a
It's a number.
that number. Okay.
Yeah, you can put it in your calculator. Natural log of 2. It'll tell you what it is. So everything on the right side is a number. Ah, I forgot this plus log of x. I didn't write it in. It's okay. So the derivative of both of those is 0. Whether you differentiate them individually or subtract this from this and then differentiate it. If you have a string of numbers all being added or subtracted, the derivative of that's always going to be 0. The derivative of any number is 0.
Okay.
Okay, but we do have to take the derivative of that. What's the derivative of log x?
Is it 1 over x? Okay.
Dx dt. Still need to do that part.
Yeah.
Okay, this one, might as well do the same thing we've been doing, huh? In other words, substitute first.
Okay.
Even though I could easily solve this for dy dt. All I got to do is move this over and divide by that. But why go to all that trouble? Let's just substitute. X is 2. E to the 0 dy dt plus e to the 0 times 6 equals 1 over x is 2, dx dt is 6. What's e to the 0?
1.
Okay, so now we got 2 dy dt plus 1 minus 6, which is minus 5, equals 3. Add that, make that 8, divide by 2, you get 4.
Okay.
Might need a bigger monitor if I have to do more problems like this. Seriously. Would help if I could get this at the top, then I could stretch it out. But
Right.
yeah, let me do the opposite. Let me put it on the bottom, and then I'll be able to stretch it out like this. All right. So, the last one, let me write it out also here. Y natural log of x plus ex e to the y equals 1. Okay? Go ahead.
So this one, do you start with y?
Yeah, like I said, if you get in a pattern and you're using the product rule, always make your first term be the same as the term on the left. I think. That way it takes all the thinking out of it. A lot of times a person can spend 10 or 15 seconds trying to figure out which one to do first.
Right.
And there's no need to waste that time. So.
Okay, so y and then times 1 over x, and then dx dt.
And it might even be helpful to put parentheses in here just so you don't ever, in other words, it's pretty easy to get confused here and forget that we still have to add part of the product rule. In other words, it would be real easy to go to this term next. So I put the parentheses just to remind myself not to forget to do the second part of the product rule.
Okay.
Which is what?
Then it would be the ln x dy dt.
Okay. And I'm going to put parentheses again, indicating that I've got to do the product rule again. Go ahead.
So x times e to the y, and then dy dt, plus e to the y times dx dt equals 0.
Okay. And again, y equals 0. Don't have to do any substitution there. What's the natural log of 1?
0?
Don't have to do any substitution there. X is 1. E to the 0 is 1. dy dt plus 1 times dx dt, which is 5. dy dt equals minus 5. Any other questions that you didn't get clarified by this?
No, it really helped.
Okay. Yeah, this should have covered all the questions. This would have been a lot harder if this would have said solve for dy dt. In other words, if they didn't say evaluate, but solve for it, and they didn't give us anything over here. In other words, they didn't give us these 3 values for each problem. Then we wouldn't have been able to use that little trick of substituting early. We would have had to do the algebra and solve all of these ridiculously hard, complicated equations. In other words, if they would have said solve this for dy dt, much, much harder than evaluate it given a dx dt, an x, and a y. I don't know if you'll have to do that or not.
Okay.
Whether it's worth us even talking about it, I don't know. You didn't have to do it tonight because we were able to substitute before doing all the complicated algebra, but it might be worth just talking about how we would solve this for dy dt.
Okay.
Well, first thing I got to do is multiply this binomial times this binomial using FOIL. Okay?
Yep.
Then I got to do the same thing over here using FOIL. Then, and again, this is all equal to 0, so I can kind of get rid of the bottom if I'm solving for dy dt, because the next step I would do would be multiply both sides by the bottom. So that makes it a little easier. But I now have 3 terms up here. I have 3 terms there, so I have a total of 6 terms in the numerator. And there is at least 2 dy dt's over in these 3 terms, and 2 dy dt's over in these 3 terms. Combine them all on the same side, put everything else on the other side, factor a dy dt out, divide by the remaining coefficient, and you've solved for dy dt. Okay?
Gotcha. Yep.
All right. Well, we don't need to take up an hour just because we scheduled an hour. If you're done, I'll just charge you for 45 minutes. And
Sounds good.
I'll let you go.
Okay, perfect. Talk to you next time.
All right, Molly. Bye-bye.
Have a good night. Bye.
You too.